So welcome everyone. Thanks for being here right at lunchtime. I hope to not let you fall asleep. I'm Riccardo Coccioli. I'm a site reliability engineer that try to keep Wikipedia running. I work at the Wikimedia Foundation. That is the non-profit organization that basically is behind Wikipedia and all its sister projects. But that's enough about me. Today we will be talking about Cumin, automation and orchestration made possible. Let's see. Cumin is a Python framework and command line interface that integrates with existing infrastructure that allows you to execute multiple commands in parallel on a selected number of hosts. And automation isn't easy, but we are trying to make it possible. Cumin basically allows and provides you a flexible, reliable, and scalable way to execute whatever commands you need to run on multiple hosts, and these hosts will be dynamically selected based on your needs. It will allow to fine-grain selecting your host. That is something that it's usually not possible with other solutions. So let's see what we will cover today. First, we will see what problems Cumin is trying to solve. Then we will go over what are the main components that are part of Cumin. So basically, the backends that allow you to select hosts from different source of truths, a grammar that allows you to combine those results, and then the transport that is basically what will be used to execute the commands on the target host. And then we will go over what are the execution strategies, another feature of Cumin, that allow basically to adapt to most use cases, and that's one of the main reasons that we started writing this tool. And then we will go over a quick demo to show you Cumin in action. So first of all, how we got here. I will tell you our story, but this story is most common, and I'm sure you will be familiar with it. So you start at the start, we have just few servers to configure, few hosts, and you start to do everything manually. There is no need of automation, no need of orchestration, no need of configuration management. Just because it's too easy, you don't bother about the complexity. Then you start growing, and your number of servers start to grow, and you start doing some quick and easy automation here and there with just some bash script or Perl script, and things start to get better, but then you continue to grow, and what you do, you start to look into configuration management solution, and you go over all of them and pick one. In our case, Puppet was selected on the fall of 2008. And then we continue to grow, then we open a second data center and basically doubled the number of hosts. At that point, the configuration management, it's still okay, we'll take care of the configuration of your host, but it will not be able to give you automation and orchestration. And more hosts you have, and in particular if you have them in multiple data centers, that's something very neat. And so we started looking for a solution of things that will allow us to do some orchestration and some automation across the fleet. And in our case, we found a solution that wasn't perfect because we didn't find anything in the open source software that will allow us to do that. But we chosen one anyway, and was sold not for the configuration management part because we were already using Puppet, but for the distributed SSH basically capability. And so we started using it. But having Puppet as a configuration management, that means that to use Salt for distributed SSH, we had to have Puppet configure salt grains on the target host to just have some host selection capability. But that was very limited, not integrated with Puppet in an easy way. And so it didn't allow us to do all the things that we wanted. And so at the end, we started deciding to write a new tool that was Cumin, and that we wanted to allow us to do all the things that the other tools didn't allow. And so basically, what we actually wanted, so the first thing that we wanted was to be able to target hosts in a very fine-grained way, in a very dynamic way. We didn't want fixed list of hosts. We didn't want anything that was tightly coupled with the current status, but something that was dynamically gathered. So in this case, for example, we would like to address hosts that are an intersection of different ensemble of hosts. Like, for example, Debian Stretch host that have a puppet class nginx with parameter cluster equal foo, and then maybe that are not pulled in the cluster foo, or something like that. So we want to be able to address the host, for example, highlighted in red and blue, but maybe not the one in black, or dynamically change this selection very quickly. And so we wanted basically something that was able to gather dynamic things from different sources of truth, different backends, that allow to gather different lists of hosts, and then mix them and combine them together with standard Boolean operators and parentheses, allowing you to write a simple query that can mix them in the way you want in that moment. The other main feature that we wanted is basically how to execute things. Sometimes you just are checking some status, grab some info, or doing some simple cleanup, and you don't need a very safe way to do it, because those are safe commands, are harmless commands that you want to execute across a fleet as quickly as possible, because you are just grabbing something around the fleet or checking some status. And in this case, you just want to run them and get the output. But in other cases, you want to do more delicate stuff. For example, you want to depull some host from the cluster, restart a service, and pull it back. And you know that you can do that, not everyone at the same time, of course, so you want to do just few at a time, and then go on the next one. So you want some batching capabilities, but you also want control over them. Because if you run some batching things across a whole fleet, you don't want just to play go, to say go and then forget. You want to check that the status is okay at all time. And so you want to be able to stop. So basically you wanted something that could do batching, but then stopping in the middle if at any point some success percentage was not met, some success criteria was not met. And so these were the two main features that we actually wanted into Cumin. So let's see for a moment how we structure Cumin. Basically what are its main components. So we have a global grammar that is the one that allows us to combine results from different backends. And from one side we have the backends, and right now we already have PuppetDB, OpenStack API, SSH non-host, and others that are coming and we are writing. But also it's possible to plug in external backends that you write. You just write a single class in Python, and you can plug in whatever backend that is not yet part of Cumin itself. And you can combine results from all of them. And it's very easy to write a new backend. I mean, it's just one file, very, very easy. It depends on your API, of course, but in general, it's very easy. And then, given the global grammar, that is basically simply having parentheses, Boolean operator, and be able to combine results of all of them, you can select things from different sources of truth, from your cluster management, from your inventory, whatever you have and you want to combine, and then use Cumin, just execute the commands on the resulting subset of hosts. And the transport is the one that allows you to execute things over the host. So right now we just implemented SSH. We chose SSH for two main reasons. In implied security, super simple. It doesn't require any dependency on the target host. So the only thing that you need is a host with Cumin master, and you don't need anything else on the target host, just as SSH server and the capability to connect from the Cumin master. But we are thinking of adding additional transport layers. In particular, we are looking for HTTP, HTTPS for RESTful API that might need to, for example, I don't know, you have an Elasticsearch cluster, you want to connect to, or multiple Elasticsearch cluster, you want to connect to the API. Or, for example, we are looking to do MySQL transport to connect to cluster of MySQL servers. So those are things that will come probably in the next future of Cumin. Let's check also what are other Cumin features that we took into account, and we are fundamentally in its capabilities. So the execution strategies are the thing that I showed you before, and I will go a little bit more in detail now. So basically, we wanted the batch size. So we have, you can select batch size, and you can select a batch sleep. Batches are implemented as a sliding window. So if you start with batch 10, it will start with 10 hosts, and then as soon as one host will finish, you will start scheduling the execution of the commands on the next host and going on. But you can select also a batch sleep between hosts. So basically, before scheduling the next host, it will sleep for such amount of time. This allows, for example, of doing things completely sequentially. You can do one host at a time with 5 minutes sleep in the middle and do a very slow rolling restart of your whole fleet, for example. At the same time, when you use batch, we have the concept of success percentage or success ratio. Basically what that means is that for each batch, you will, at the end, when every host completes the execution of a command, it will calculate the success percentage of all the hosts that have executed already a command. And if that percentage is over your threshold, then it will go and execute and schedule the next host. Otherwise, it will stop because it says that it considered that a failure. So you can, by default, he has a 100% success ratio. That means that at the first fault, it will stop. But at the first failure, sorry. But you can change that and decide what is your success acceptable ratio. By default, Cumin consider every executed command that exits with a different from 0 exit status as a failure. But you can, of course, change that via a command line option, or if you're using it as a library in Python, you can define the whole list of acceptable exit codes that you consider successful. And that, for example, in our case, is very useful with Puppet, that usually has different exit code even if they're successful, but in test mode has a different exit code. The other things that you can do are timeouts, so basically per host timeout. So every command that is executed in each host, you can set a timeout, or you can set a global timeout of the whole execution, given what are your needs, basically. Other small features are, for example, interactive mode, that basically when you run Cumin, at the end, it will run normally, but in the end, instead of just exiting, it will drop you into a Python shell in which they are already preloaded the result, and you can mangle the results directly in a Python shell. And that's pretty useful in some cases. And the other one are different output formats. So by default, it just prints the output, but you can select a JSON or TXT format in which they will be printed in an easy way for post-processing in a with different tools, basically. And the other feature of Cumin that is inherited from the library that we choose to do SSH, that is cluster shell, that is a very powerful Python library that comes from the HPC world, and is to aggregate results. So basically, when you run the same command across the whole fleet, if they have the same output, all the hosts that have the same output are grouped together, and you will just see one line with the list of hosts that match and the output. So if you're running this over 100 of hosts, you don't have a very long output, but it's much more compact and very useful for checking things and immediately understand how many hosts have that output and how many hosts and which one have a different output. So let's see for a moment a quick demo of Cumin in action. Let me see if I can. Sorry, once less. I hope is visible. So first of all, let's take a quick look at Cumin options. So as you can see, this is, of course, everything that I'm showing here is using Cumin as a command line tool. It can be perfectly used, and it's very simple as a library, Python library. So you just import Cumin, and in the documentation, it's very clearly, there are a lot of examples of how to use it. So basically what you run is Cumin, a host query, that is your query that you want to select the host, and a series of commands that you want to execute, one or more. And by default, it reads a configuration that it's usually in TC Cumin, but you can change it and you can pick a different one. The mode is it's a very specific thing that we decided to do. So basically, when you are running multiple commands, you have basically two ways of doing that. I mean, there are many, but the most common ways is I want to run this command on all the hosts, and then if it's successful, run the second command on all the hosts that were successful. So basically you can run the first command of 100 hosts have on, I don't know, 10 failures, and that 10 failures is within your success ratio, and then you go and you will execute the next command only on the 90 hosts that were successful. If instead your success ratio was, I don't know, 95%, that will not match, will just run the first command and stop. And this is what we call a sync mode, basically. And then there is the async mode, in which you don't care about this synchronicity about the cluster, and you just run the first, the second, and the third command, or whatever they are, in each host independently. So in each host, if one command fails, it will not run the others, but it will not wait for the other host. So they are independent between them, and they are basically vertically independent, and each one will execute their commands. So then we have the other options that we'll see that are basically the batch, the timeout, output, sleep, interactive mode, and all basically the option that I talked about. And then let's see how we can do basically a simple query. In this case, we are using PuppetDB as a backend, and so this is a very simple syntax to say I want all the hosts that match class nginx. And given that I didn't put any command, it will assume that it's in dry run mode and just exit after listing the matching hosts. The matching hosts also, they are listed in a very compact way. This is also thanks to cluster shell library that use a node set that are basically Python sets, but with additional features. And one of those is basically to automatically compress the host in a very compact syntax, in particular if you have number range in your host names. And so basically, for example, to say just the PuppetDB Puppet class that is applied, we do that. And in this case, we are just checking all the hosts that match a resource of type file, whose title is that one. So basically, we are checking if that file is managed by Puppet, that will be recorded in PuppetDB as a resource, a file resource, and the title of that file resource is the path, usually, the path of where you are saving it, and you can check very quickly and target those hosts based on specific resources. So not only classes, but also very, very specific resources or facts. In this case, we are using the kind of new paradigm of Puppet roles and Puppet profiles. So in this case, it's a role. It's a role called MediaWiki App Servers, and this will match the hosts that have this role applied to them. And this is a slightly more complex query that is using the global grammar. So in this case, I'm mixing things from different backend. It's just an example. They are both PuppetDB backends, but are different queries. So I can do queries that PuppetDB API don't allow me to do. And I'm asking for all the hosts that have a class nginx, and also all the hosts that have a fact that says that the distribution name is Jesse, is Debian Jesse. So in this case, I'm getting a sub-selection of hosts, and I can do and not, or, XOR, and combine them with parentheses. So basically, there is no limitation for the combination of hosts. As you can see, this can become quite long. The queries can become quite long. So we develop aliases. Aliases are basically a configuration file, in which you can just say, I want an alias. In this case, AMW is an alias for us. And that can be a very complex query. It doesn't matter. It's a configuration file. So all the common queries that you might have, you can just save them in an alias, and it will be very, very easy to recall them when you want. So in this case, let's run a very simple thing. I'm checking if Apache 2 process on systemctl is active on a series of target hosts, and I very quickly can see that one host has it inactive, and all the other hosts have it active. And Cumin is telling me very clearly at the end that 1% that the one host didn't execute it, that failed, because the exit code of that command was not 0. And it lists me where are the hosts that succeed. So from these, I can basically just, if I want to do some next command based on this output, I can just copy and paste the list of hosts that the subgroups of successful and failing hosts are there, and use Cumin again with that list of hosts, because I can just put those things there. So a little bit more complex example with 2 commands, because this was just a single command. We can run the same thing, but then I want to get the status to know since how much time the the service was active. And in this case, it will just run as the same concept, but I can show you better here. So as you can see, I'm using the async mode in this case, and what I'm telling is basically to run those commands independently, because I don't care to run the status on all the hosts and then to run the is active on all the hosts and then running the status and grabbing for the time it was active on all the hosts after that. I just run both commands on all the hosts at the same time. And as you can see, group the output together, so I know that 44 hosts were basically Apache 2 was restarted 3 weeks and 4 days ago and was most likely for a security upgrade. And in this case, I'm using batches, so it will be a little bit slower. I'm using batches of 5, and I set a success percentage of 80. That means that I accept 80% success and only 20% failure for each batch of 5. And I know already that, given this same list of hosts, and in this case, it's using the sync mode. So basically, in this case, I'm running first one command on all the hosts, and then the second command only on the one that succeeded. And so this is going slowly because it's a batch of 5, and we'll do the same. So this is a very quick example of how we use Cumin every day at the Wikimedia, and we have really had a lot of good results so far, and a lot of people are using it. So just to recap, we have seen that Cumin has a powerful query syntax to select hosts, allow to have multiple execution strategies. It aggregates the output in a smart way and reports reliably all the failures. Can be used as a command line tool or as a Python framework library in your other automation or orchestration tools. And to have more information on how to find the source code, the releases on PyPy, releases on GitHub, documentation, and how we use it at Wikimedia Foundation, it's all listed on all the links are listed on the page, on the FOSDEM page for this talk. And all my contacts are on the speaker profile page on FOSDEM for this talk. And you can find them just searching for Cumin, FOSDEM, and optionally my name on any search engine. So thank you very much for being here, and let me know if you have any questions. What do you mean?
This is a sort of deployment scenario where you have redundancy.
Yeah.
So for example, if you pass the 80% successful part, you can say, okay, you can start switching over load balancers. I don't care about the last 20%.
Okay.
It might be a bit slower, maybe 1% will fail, and I have to.
So for that, you can set a very small timeout. So if your normal command is, 10 seconds, you can set a timeout 20 just to be on the safe side, and that will fail quickly. The other option, it doesn't have exactly that feature, so that after success already start the second one, because we want to be reliable and execute. Like if you want to do in sync mode, you execute the first one on all of them, because you don't know if the next one will be actually success or failing. So you can do that with a short amount of short batch.
So this threshold for success, what do you use it for normally?
Like when you use batches, it's calculated for each at any time a host execute a command. So when you finish to execute a command, it will calculate the success percentage, and if it's not met, it will not schedule again, and it will stop there. But
It's a safety.
yeah, it's a safety feature, absolutely. That's because like if you want to do a batch of 3 and then I don't know, you accept one failure on every 3, but it calculates on the whole thing. So it will go. But if the first 2 fails, it will stop, for example, because in the first batch you have very few hosts, and it's a safety feature, definitely.
Okay, that's all we got. So it's time for Ricardo again.
And I'll be here for if you have any questions.
We'll be outside. Thanks a lot.
Thank you very much.
Yeah.